Let f and g be the functions defined by f of x equals 1 plus x plus e to the x squared minus 2x, and g of x equal to x to the fourth minus 6.5 x squared plus 6x plus 2. Let R and S be the two regions enclosed by the graphs of f and g shown in the figure above. Part A. Find the sum of the areas of regions R and S. Okay, so the first thing that you need to do to find area is graph the two functions in your graphing calculator. I have f of x on the top and g of x on the bottom. The second thing you need to do is find where the graphs intersect. So you'll do second, calculate, intersect. And find that the graphs intersect at this point. Now you'll use the intersection point to calculate the area. You need to do two different integrals because a graph on top is different. For your first integral, you'll go from 0 to the intersection point. For the second integral, you'll go from the intersection point to 2. Now, using your graphing calculator, you can calculate the area in between each curve. You'll need to know which curve is on the top. For the first one, g of x is on top. For the second one, f of x is on top. Okay, so in my graphing calculator, I have the graph of g of x minus the graph of f of x. And now I'm going to calculate the area. Okay. So I'm going to go from 0 to the intersection point. And I'm going to do the same thing for the second integral. Now in my graphing calculator, I have the graph of f of x minus the graph of g of x, and I'm going to calculate the area again. And I'm going to go from the intersection point to 2. Now I'm going to add these two values together in order to get my answer.
Part B. Region S is the base of a solid whose cross-sections perpendicular to the x-axis are squares. Find the volume of the solid. Hello, so in part B we need to find the cross-section area to find the volume of region S. In doing that, we need to use the formula A of x to find the area for the cross-sections. And since we need to find a square region, because that's the length times the length, so the area equals the length squared. The A of x is also squared. So then using our integral from our point of 1 point blah blah blah, we go to the end, which is 2, and then we plug in the top minus the bottom, which is f minus g. And then we subtract and then we square it because we're using the squares. So you take your f of x minus your g of x and then you square it all and make it all pretty like that. And then you press second to calculate to number 7, press enter, and you enter your lower limit, which is the intersection at the start of S, which is 1.032832. Press enter, and you find your upper limit, which is 2. Press enter, because that's the end of it, and then you get your answer, which is 1 5.283 and circled.
Part C. Let h be the vertical distance between the graphs of f and g in region S. Find the rate at which h changes with respect to x when x equals 1.8. Okay, so for this part, we're going to try and find the rate of change, which we'll use h of x, and set it equal. And since we're finding the region of S, it's f of x is on top and g of x is on the bottom, so it's upper minus lower. So it's f of x minus g of x. And the rate of change is like the slope, so we're trying to find the derivative. So we'll go, So we'll go h prime of x equals f prime of x minus g prime of x. So then we have that, and then we're substituting in what we're given. So we're trying to find h of 1.8. So that equals f prime of 1.8 minus g prime of 1.8. So then if we go over to our calculators, we plug in, we plug in f of x and g of x, which is down there. So we're on our graph and we're trying to find the derivative, so we hit second and trace. Our calculators can find the derivative, we just have to go to number 6, and since it's on f of x, we'll type in 1.8 and hit enter, and it says our derivative is 2.116, and then to find the derivative of g of x, we have to hit down, so we're on the g of x, and we type in 1.8, and it gives us our derivative of 5.928. And then if we type that in, plug it in, we get negative 3.812 as our answer of h prime of 1.8, or our rate of change when the height is 1.8.